Share my screen. So today and tomorrow we're going to be talking about, I guess, more advanced functional things, functional programming. And today we're going to focus on Lambda functions and list comprehensions. So we've seen both of these a number of times in different situations, but haven't explicitly talked about them. So both of these, you don't need either one of these in Python. You can do, I don't think that there's anything that you can't do without them, but they do make things more concise and arguably clearer once you understand how they work. So you can take a look at the README. We're just going to go through some examples. So we can talk about lambdas first. So I'll use the picture. So here is the basic structure of a lambda function. So does anyone happen to know what a lambda function is?
You said it was kind of equivalent to like an arrow function in JavaScript. So it's like a one-liner.
Yep. Yeah.
Anonymous.
Mm-hmm. Yeah. So it's like a one-line anonymous function. So in JavaScript, the syntax for that is arrow, and then so you have the parameters and the arrow, and then whatever you get to return. The arrow function in JavaScript is more flexible. It doesn't have to be just one line, but with Python, the lambda can only be one line. So, I mean, you have to have one expression here. So you can't have like a for loop or something in here. So you have the keyword lambda, and then here, whoops. Yeah, that'll be fine. So here you have whatever parameters you've taken. This could be nothing. It could be several, and these would be separated by commas if there are several of them. And then we have whatever you want to return. So this has to evaluate to a value. So in this case, we're just multiplying whatever we pass in by itself. So this is the basic structure. We can look at, let's look at some examples of lambdas. All right, so we can go ahead and I think we can start with the simplest possible, or maybe the simplest possible lambda, which is an identity function. So something that takes something and then returns that something. So we'll call this, you get the keyword lambda, which you always have to have, and then whatever parameter, and then whatever we're returning, in this case, x. So that is a lambda function, and this is in fact an anonymous function, and we're just assigning that function to a value because functions are first class objects, so you can assign them to other things. So if we want to call this function, how would I do that?
Like x equals identity and pass something into the x. Or I guess it can't be x, anything else probably. I guess x is still allowed probably, even though x is in the function because it's not in the context. So right. X equals lambda parentheses whatever number you're passing in.
So yeah, so when we write the lambda function,
I'm sorry, identity. X equals identity.
Okay.
Parentheses whatever you pass in.
And just to make it confusing, we'll pass in an x. And we get an x, right? So let me, just so we're not, we'll make it an O. Okay, so we're gonna get an O here. So we wrote an anonymous lambda function and we assigned it to this variable. And because this variable is a function, we can call it. We call it with this parameter, and the function takes one parameter, and then we're just, it takes one parameter and returns itself. So whatever it takes as a parameter, so we can print the value. So it works just like a normal function. We could do the same thing with def. Okay, we get the same thing.
And Chad,
So,
just to
yeah.
be clear, the X's that are on line 2 and 7 don't have to be X. They could be anything, right?
Yeah, yeah. Just like this, we call this. This is just the parameter name. We can call this whatever we want. So what does anonymous mean? Well, we can print. Let's print the regular function here. We can see that it's a function and it's called identity, and it has a memory address. That's what happens when we print this one. What happens? Confusing. So what happens when we print this identity? Well, now we don't get a name. So it's anonymous. So any lambda function is going to look like this. So for the most part, that's not really a big deal. But if you're using lots of lambdas and maybe even lambdas within lambdas, and you have an error or something like that, it's going to be harder to figure out where the problem is occurring because you don't have a name to work on. So that's one drawback of lambdas. Okay, so let's look at another lambda, another very simple one. So this time we'll write a lambda that doesn't take any parameters. Call it okay. So now we have the lambda function. We have no parameters, and this will get evaluated when we call, and it's just going to print hi. So we'll call the function, and we get hi. So lambda expression, it looks weird maybe, and it's got like this very intimidating sounding name, but it's just a function. So the syntax is slightly different. In fact, it's simplified and it's a little bit more limited, but that's it. So let's look at another example. Let's see. Okay, let's look at one with we have a lot of parameters. So So we get A, B, C, D, and we'll just return a, this, I mean, this is, doesn't really even matter what we're doing here. Times D. And then we'll call the function. We have to pass it the values we want. So and I have to print it. And we get a nice round number, 360. So again, it's lambda. You always have to have this keyword lambda, just like def if you want to write a function, right? Or a regular function. So you have lambda keyword, then you have, optional 0 or however many parameters, and then you have whatever you're doing here. So we can also, so we can really only do one thing here, but we can play around a little bit. We can use like a ternary, what is effectively a ternary operator. So we can do, we'll return this value if A, so if A is even, let's try running this, and we get no. So this is, I mean, you can stretch it and do some more things, but in terms of readability, there's like lambdas and this comprehensions, which we'll see in a second. You probably want to be cognizant of readability here, but you can have some logic here. Just keep it to a minimum. Are there questions about this?
So this is really similar to the equals arrow in JavaScript.
Yeah. So if
Okay.
this were, let's just look at that. So I'm going to copy. All right, we'll do this one, I guess. We'll see, my JavaScript is rusty. So we can do this and what? How do I run a JavaScript file again?
Node.
Yeah. So 840. Is that the same values I had? No, 3, 4, 5, 6. Okay. So this should look, I mean, it's very similar. The difference is that with JavaScript, if I want to make it complicated, I can just throw on some curly brackets and I can do, whatever normal stuff I want to do in a function. So I can add.
Basically, you just run that blocker code.
Basically what?
You can run a full blocker code, everything you put in those.
Yeah,
curly.
yeah. So I can have, a 500 line function that's an arrow function, as long as I use these curly brackets. If I don't use the curly brackets, then I'm restricted to one line. So you could think of a Lambda function as an arrow function without curly brackets, if that's helpful for you. So it's kind of like yeah.
So the use of anonymous functions, that's all going towards functional programming and not assigning variables that are pointless, sort of thing, or I guess I don't understand the benefit of it really.
So again, I would say that you do not have to use anonymous functions. I don't know that there's anything that you can't do without it, but it's a convenience. There are cases where it is we'll look at uses in a second after we run through some examples looking at the syntax. But if you just want to do something like a quick one-off kind of thing, like, you know, something like multiplying a number by itself, arguably it's just clearer and simpler to write a lambda instead of writing a separate function. We'll look at a couple examples, so the use case should be a little clearer. All right, so one other thing you can do with a lambda, which wouldn't necessarily actually do, but so what is an immediately invoked function expression?
Is it a function that's called when you create it instead of later when you like call it?
Yeah, but basically you call it where you create it. So as soon as the file is run, the function executes. So it's like combining the call. So we'll look at that real quick. Again, you can do this in JavaScript as well. You can go ahead and let's do. I don't know if you have to use brackets. Probably have to use brackets here. This might not work with. I have to wrap the whole thing. That's right. So let me do that. So let's probably shouldn't assign it to a value. So let me do console.log. So this ran, and again, I should be able just to get rid of this as well. So all I did was run the file and this executed. So I create the function here and then I call it immediately. So it's an immediately invoked function expression. So you can do that in JavaScript. You can also do that in Python with lambdas. So we'll just do, yeah, I guess we'll do the same thing. Sorry. All right, so if we run this again, it executes as soon as we run as soon as this line hits, the function runs. So in JavaScript, ifs have some utility. I don't know that I've ever seen an ify in Python, but I'm sure there's a use case. All right, so that's immediately invoked function expressions. You can also do, so this will be a slightly more complicated example, but as I mentioned, it's a function. So functions are first class objects, you can return a function. So you can have a function that returns a function, right? So you can higher order function. You can do higher order Lambda functions as well. So there's something called currying, which we'll talk about tomorrow or Saturday. So we have a Lambda function that takes a parameter, and we return another Lambda function that takes a parameter. And the second function will, let's say, return a plus b. So again, the inner function that's getting returned should just look like a normal Lambda function to you. And the outer function, we have a Lambda function that takes in one parameter and returns another function that takes a parameter. So then we can partially apply or curry this function. So we'll call this outer function, and it's going to return another function. So this inner function won't execute yet, but we're going to call this outer function. So this function will be basically like loaded and ready to go with whatever parameter we pass now. So curried 5 equals so I'll print this function. So notice that, this didn't in some senses, this didn't execute. This outer function executed, and this outer function returns an inner function, but we haven't called the inner function yet. So now the way we have it is this inner function is preloaded basically with a 5 here. And this works because of something called closures, which again, we'll talk about more on Saturday. But so now we have this function, it's preloaded with 5, and we can then call the inner function. So let's say 15 equals, we'll call curried 5 with 10, and then we'll print curried 15, and we get 15 as a result. So again, Lambda function takes in a parameter, which is what we're doing here. This outer function executes. This curried 5 doesn't return a value, it returns another function. And this inner function has access to this first parameter. So we call this, and then this executes. And when this executes, we pass in b, but this inner function already knows about the value of a from here. So we could also do so that should also work. So just like the first one, we're calling it with 5, and then whatever that returns, which is a function, we're calling with 10. Okay, so this is a more, and we're kind of not so much talking about lambdas, and now we're talking about currying. But are there any questions about the syntax of Lambda functions? Okay. Yeah.
Are there ways to do these kind of anonymous functions that are longer the way that there is in JavaScript with the longer brackets, or with the with the curly brackets?
I don't think so.
Just not like that.
There are some tricks you can do, again, like the ternary, it's not really ternary operator, but this kind of ternary expressions here. You do if else, and then you can also, if something else, then call another Lambda function. So you can definitely make it complicated, but there are limits to what you can do, and then there are even harder limits on when it becomes totally unreadable.
If your code is unreadable, you're breaking Python practices, basically. So if you're trying to make a Lambda function work, trying to find some hacky way to make it span a bunch of lines, or it's super complex, like you have a lambda and a lambda and a lambda and a list comprehension, it's just like, if you can't read it, you need to write it a different way.
Yeah.
It's just like if Chad types into the Python REPL, import this, you'll see like the general thought process for Python. It's like the Zen of Python, as they call it. And it talks about just like explicit is better than implicit, just like general rules to follow. And you'll learn them. You're not going to know them off the bat, but like a Lambda function, you almost don't really ever use it unless you need a function, because you have to pass a function as an argument, but you don't really need it to exist beyond the line that you need to use it on. You just need to use it one time. You need it to exist for one specific thing. You don't need to even reuse it again ever, just on that one time. And then normally that's like, I can just use a Lambda function for that. But beyond that, you wouldn't do like JavaScript where you like assign an anonymous function to a variable. That kind of defeats the purpose of assigning an anonymous function, because you just gave it a name. Now it's not anonymous anymore. But yeah, there's all kind of like, people will get in fights over this stuff, just like technicalities, and you just got to make reasonable decisions and write readable code. Don't overcomplicate. Go ahead.
Do we have time to see it like within a slightly larger?
Yeah. So I'll show you how you would actually use a Lambda function in a sec. I just wanted to make sure that the basic syntax was clear first. So as Chris was saying, I just want to point out this kind of funny. So this is actually in the official Python docs about, so this is, Python.org, whatever. And here's a comment. So Frederick Lund once suggested the following set of rules for refactoring uses of Lambda. 1, write a Lambda function. 2, write a comment explaining what the heck that Lambda does. 3, study the comment for a while and think of a name that captures the essence of that comment. 4, convert the Lambda to a def statement using that name. 5, remove the comment. So yeah, not everyone, it's a thing that's available, and you can argue about when it's appropriate to use, if it's appropriate to use, so on. But you can definitely overuse lambdas. Okay, so let's talk about how we could actually use a lambda. So a typical use case would be in a higher order function like map. So if we have an array, and let's say we want to return a new array where all of these values are doubled, right? So you can do this, and we'll do map. And how does map work? In Python or JavaScript, so both Python and JavaScript have map functions, which do the same thing.
Is it something specific with that variable or something? When you map to it?
Yeah, so map will do something to each item in the iterable that you pass it. Okay, so map.
It'll run each element of that iterable through whatever function you pass, and then once that completes, it returns the new list in this case.
Exactly. So the first parameter will be a function. So I'll just call it f for now. And then the second parameter will be the iterable, in this case, nums, right? So what function should we pass it? Well, if it's just a quick thing, like we want to double everything, we could just write a lambda function. Lambda so we'll print doubles. And we get a map object. I should have mentioned that. So there's a slight difference between JavaScript and Python, but this map object can be converted into a list. So we'll also talk about generators on Saturday. We'll talk about a lot of things on Saturday. So now we have our new list. So we started with this, we mapped, so we ran this function, which in this case, we gave it a lambda. So we ran this lambda function for every element in this nums iterable. So we could have done something like this, def double num times 2, and we'll get rid of this. Then we get the exact same result. So again, you don't have to use lambdas, but this would be a typical use case where you use lambdas. So if I don't need to use this function, it's not useful to me anywhere else in my code. Maybe it's like, what's the point of creating another function somewhere? Or if this were in a class, maybe we'd have to make a method, an instance method or a static method or something like that. So why do that? That's just extra, and it's making it's in some ways it's less expressive of my code's actual intention, because what I really want is for this just to do something very simple, and I don't need another named function available to me. So this is a typical use case. Filter, again, like filter, you would do the same thing. So let's do an example of filter. And we'll filter all the even numbers. So again, map will take two things. It takes a function and it takes an iterable. So we'll pass it a lambda function, lambda num. The difference is that this will have to evaluate to a Boolean. So forget that if I filter odds or evens, but whatever. So if we want to get all the odd numbers here, and then convert that. That's not what I meant to do. Sorry.
It's actually filter.
What am I doing? Thank you. So now I get this filtered list. So we have map, filter. There's also reduce. So in JavaScript, those are like the big three higher order functions. Python also has a reduce, although it's kind of moved in. So there are discussions, in the Python community about whether you should have list and, we should have filter and map, and so on. Because as we'll see when we get to list comprehensions, you can do the same thing with those. Okay, so that's Lambda functions, and that's how you would use them typically. Any questions about that? All right, let's move on to list comprehensions. So again, we'll start with these very simple examples. So the first thing we can do is if we want to copy an array. So we have an array, and so I can just do this, right? And then print. Right, so that works. Does that work? Did I, in fact, just copy an array?
No.
Okay, thank you. So I could check that. One way I could check that is to check the ID. So give me representation of the memory address. And look, it's in the same place in memory. It's the same thing. So copy is actually not a copy. It's just another name for the same thing. So if we want to copy, a mutable data type, such as a list, there are a number of ways to do it. But one way to do that is to use list comprehensions. So we can create a list comprehension, and the basic syntax for that. Let me go over here. So I'm going to talk about list comprehensions, but you can actually have their dictionary comprehensions and set comprehensions. But 90% of the time you're going to be doing list comprehensions. So you have an expression which could just something that evaluates to a value. This could be a call to a function. This could just be a particular variable. And then for item, so it's just like a for loop, right? For any given item in the iterable. And you wrap that in curly braces, or if you're making a list, sorry, you wrap it in brackets if you're making a list. And that's basically it. So this is the basic syntax for a list comprehension. So let's try that. So first let's do num for num in original. So we'll print this out, and we can see that copy and original are actually two different things. Let's print out the actual things. So they look the same, but they're two different things. They're in two different places in memory. So again, basic syntax is whatever I want to show up at this given spot for any thing in the iterable that I pass it. So that's copying. All right. We can also, so this is like mapping, but not doing anything. It's like mapping using an identity function. So we can also filter. So if we have our original here, we can do, let's just call it So we have our brackets, and then we'll do num for num in original. So this will give us, just so we did above, this will give us everything, but we want a subset of that. So we can actually add a conditional here. So if num modulus 2 is 1, original. And we just get 1 and 3, the odd numbers. So the syntax gets a little wonky when you start getting more complex. You can also have, you can operate on multi-dimensional arrays as well. You can see an example of that. But the basic syntax is whatever you want to show up for a given item in the array, and then you can tack on conditionals and other things. Okay. So let's try. What could I do? Let's try something like this. So str. So you can also call a function here, right? So as long as this evaluates to a value, you can do that here. So we'll convert this to a string. We can see that instead of an array of, or sorry, instead of a list of integers, we have a list of strings. And you could also call a more complex function here, right? So we can have def, I don't know. And we can call this and print this out. So now we get whatever random thing we get here. So we could also replace this with a lambda, right? So so you can just use the bare value itself. You can modify the value. You can call a function with the value as long as one thing gets returned. And just put +8 here, right? Let's make this a lambda. Could anyone care to convert this do something function into a lambda?
I think it would just be lambda num colon, and then essentially the return statement. So num times 80 plus 34.
Okay. And that's going to return an actual function, right? So I could do something. This is ridiculous and you wouldn't actually do this, but just to show you that, this is a very flexible, it's a very flexible, very Pythonic way of doing things. So Chris was talking about PEP standards and, doing things Pythonically. So a list comprehension is at the tippy top of the Pythonic mountain. right, let's look at, we'll just look at one more example where we have a more complex statement. So we'll have two arrays. So let's do, all right, so I have two arrays, and what I want to do is I want to get, I want to have a list of tuples that contain all of the possible pairings from these two lists. So I can create a list comprehension, and I know I'm going to have, I want to basically return a tuple. So I want to have a list of tuples. So I'm going to have to do something here, and I want it to be a number and a letter. So what I have to do is number, letter for number in first. So let me just try, let's just do this first. We'll print pairs. So no surprise there. Actually, it is a little surprising. I guess it should be the trailing comma. Okay, so now I have a bunch of tuples. One tuples. All right. But I don't just want 4 things, I want a whole bunch. So whatever, 16 things basically. So I want to have a letter, so a number letter for num in first, and I can tack on another one for letter in second. So the syntax starts getting, I think list comprehensions start getting very difficult to read, just like lambdas, once you start making them too complicated. Let's see what this does. So now we have a list of tuples with every possible 1A, 1B, 1C, 1D, 2A, 2B, 2C, 2D, and so on. So we're getting num and letter, which are just, any old names that we choose for whatever thing in the first one. And then basically for every iteration on the first one, we're also going to iterate over everything in the second one. So yeah, that's the basics of list comprehension and lambdas. So you could basically do anything with a list comprehension, like filter and map in Python arguably are not necessary because of.
So Chad,
needs-
how do you
yeah.
use this on your job? How do you apply this knowledge on your job?
It really depends, but this is just another way. I mean, this is a common kind of task where you need to create an array based on another array or something like that. So mapping, filtering. If you were, if you had a JSON object, for example, if you had a JSON object that had a bunch of entries, we haven't talked about JSON yet, but it's just like, it's basically an object. You can think of it as an object, and you got a return value, a whole bunch of stuff in it, and you only care about 1 or 2 values. You could use a list comprehension to filter that. So if you have a list of objects you get returned as JSON, you can convert that and then use a list comprehension with a filter to look for the specific key that you want, and then you could start working from that subset.
So in this example, when you have the two kind of layered into this list comprehension, is everything from parenthesis num letter parenthesis for num in first, is that all like acting as as the expression, and then it's like another layer in it, or is it just like a kind of keyword type of thing where if you have two fours, it's just that Python knows how to do that?
So I think this would count as the expression. I don't know if I don't think Python would count this as embedded. I think it would just say that there's one expression. I don't know if Chris has any thoughts here, but I think that the tuple is the expression.
So it's kind of chaining from left to right. It's not like doing I can't think of how to explain it, but like it's not doing it. It's not like taking it up into another layer. It's just going from, it's doing the first
It's a nested loop.
into, and then this, yeah, it's not like a nested loop.
It is a nested
It
loop.
is, yeah.
It's as if you did a nested loop, and then the left side is what it's basically appending to your list as it iterates.
So I can just write that out. So for
Yeah, write the long way out.
in first, second, and I'll have to create another return array. So
You commented out second.
thank you. So this does the same thing. So if you look at the README, so one reason you would do something like this using map or filter or list comprehensions is, so there's this, conceptual binary. So you have a declarative style and you have an imperative style. So this would be more of an imperative style where I have to kind of go in by hand and tell Python every single detail. So create an empty array, iterate over everything in first, and then assign everything in there in turn to this variable called num, and then do the same thing here, and then append this tuple to pairs, and then print pairs, right? Whereas a list comprehension, it's a little bit less, it's a little bit more abstract. So you're not really telling Python the details of how to do this.
And in programming, when something becomes such a common pattern that programmers are constantly repeating that pattern over and over, they end up making some kind of built-in. That's where a lot of built-ins come from. So line 19, 20, 20, line 19, 20, 21, and 22. Programmers do this a lot. They define an empty list, they iterate over some kind of other iterable or list or collection of something, and then they want to perform a calculation and append it to another list. And it's such a common pattern that they're like, let's invent something that's, we can compress into a more concise line. Like I can get rid of 4 lines and make it 1 line. And, as long as it follows that pattern, then they can do it. So you have like a list, and it's not just list comprehensions. They call it comprehensions because you can do it with any collection type. You can do it with a set, a list, a dictionary, or you can pretty much do it with any data type you invent that's a collection, like anything that's an iterable. the rabbit hole goes way deeper on that. But yeah, anything that's a common pattern like that, you can just compress into a comprehension. And yeah, you'll get to generators. Basically that line that Chad is writing, that's a list comprehension line. If you took the brackets off, making it a list, it actually becomes what's called a generator. You can't run it without parentheses around it, but once you do, it becomes basically something called a generator object, which works inside of anything that's you can iterate over. And I'll stop there.
Yeah. Yep.
Yeah,
We'll talk about this on Saturday, but yeah, so this is a generator, and then you could convert that to a list. So
Can you on line 17, could you put brackets around pairs, and would that work? Instead of using the list.
I mean, no, I think it would just give you just have a list with one thing in it that would be a generator expression. So yeah.
But it works on 16 because it's a special thing that Python does.
Yeah, exactly.
yeah, list is a class, and it knows how to iterate over something. So if on line 17, Chad, if you put like a string in there, or do print and then list like you were doing, like list like you did before, and just put like a string of characters in there, just like A, B, C, D, all as a string, like the list.
Like here?
Yeah. So just put quotes A, B, C, D, and then print that out, and or you are already printing out, and it turns it into a list. So it iterates over the string and puts it into a list. So it's doing like a loop for you in that call, because list is a class, and so when you call it, it takes your argument and tries to make it into a list. And one of the things it does is it's going to iterate. And generators, you have to iterate over them to get values out of them. They're a weird thing. They do something called, they don't return values, they yield values, but you guys will talk about that on Saturday. But yeah, they're a weird type.
Yeah. And we'll also talk about why you would want to use the generator. For example, if you had an array that was larger than your memory, because anyway, we don't have to talk about that now. But okay, so lambdas and list comprehensions. Are there questions specifically about the syntax for either lambdas, or how they're used typically, or list comprehensions? So don't worry about complicated list comprehensions or complicated lambdas. If you understand the basics, that is fine. Okay. Stop recording.